O'clock, so let's get this show on the road. Good morning, everybody, and welcome to our final webinar before our summer break. Hopefully you've been enjoying this series. Today we're going to be exploring how tax technology can help you, and we have a slightly different topic and one I hope you're going to find very useful. As always, the housekeeping points, today's session will be recorded. There's an opportunity for questions. If you can ask them through the Q&A on Zoom, that would be appreciated rather than the chat. There will be a follow-up from today's session for those that want a deeper dive. And as always, we will keep it to 30 minutes. So on to our main event. I'm Ian Bowden, tax partner, head of BDO's Tax Automation Group. The purpose of these webinars is to explore the art of the possible. We run these sessions to help raise awareness of options that are available to help you, all in search of finding a better way. We pick a different topic each month and with a different special guest. We have covered quite a bit of ground. The videos from all the previous sessions are on our website, so please do check them out. I mentioned today's session was slightly different. As many of you know, we do focus as a team on three key areas. That's optimizing your existing systems, implementing third parties, and targeted automation. Today's session covers a little bit of everything, and I'm really interested to hear what our special guest has to say. Today we are exploring artificial intelligence and ask the question, will it replace us? Is it real? How real? Will Skynet eventually take over the world, or is my job safe for now? Delighted to be joined today by Ben Taylor. Ben is the CTO of Rainbird AI, which is an organization that's focused on harnessing AI to help automate our world. Quite a bold statement there from Ben. Ben also sits on the all-party parliamentary group on AI, and I've had the privilege of meeting and speaking with Ben previously when we've had some interesting conversations with HMRC, shall we say. He's got some real-world experience that he's going to share with us today, so thanks very much for joining, Ben. Before we jump to Ben, as always with these sessions, we do like to provide a quick market overview on the topic. And joining me this morning to discuss all things AI is Ian Bacon, who's our head of delivery. Over to you, Ian.
Thank you, Ian. Good morning, everyone. So as Ian mentioned, there's an enormous hype in the marketplace around AI at the moment, particularly since the public release of ChatGPT late last year. Often it is presented as the solution to everything. But what is the reality, and what are we actually seeing in the marketplace? In short, the promises made by AI promoters versus the realities of real-world delivery can be vastly different. But why is that? Is AI useful to us in the tax process? Why should you be interested? And more importantly, can you trust it? Some of these questions will obviously be answered by Ben, so I don't want to steal his thunder, apologies. So I thought it best to provide a brief history of AI in order to provide you with some context as to the way we see it being deployed in the marketplace thus far. So artificial intelligence started life in the 1950s, shortly after the creation of computing. That's right, 70 years ago. At that time, there were two primary approaches, logical models and learning through examples. For the first few decades, the logical models dominated, but as access to greater computational power became cheaper and large amounts of data became ubiquitous with the advent of the internet, real breakthroughs started to happen with the learning through examples approach. This is what most AI that we interact with today uses, and you'll often hear the term machine learning or ML used, and fundamentally that's a branch of the AI that we have. You have interacted with many of these by your voice assistants at home, Siri, Google Assistant, Alexa, image recognition, which helps you find your photos, to name but a few. Not too long ago, in 2017, Google published its Transformer paper, which put forward the idea that attention was needed. Essentially, that means focusing the AI models on a particular field to allow it to learn that field was important in order to advance AI. Now, attention came out of that. What is important in what's being asked? Prediction. What does the AI need to do? And embedding was the way of creating relationships and connections between what we might consider disparate data, but essentially what we as humans are able to make decisions around. That's what we're very good at. But fundamentally, AI is only as good as the source data that the models are trained on. Inaccuracies in the training of source data will result in errors in the AI's output, much like if we read the wrong information, we will repeat that wrong information. In AI, those are termed as hallucinations. But for any discrete application today, AI is generally much better than humans. It makes far fewer errors than humans, providing it is trained properly. So what can we use it for? Why should we, you look into it, particularly in the tax space? At BDO, we see AI as a companion tool, a co-pilot, if you like. When staff treat AI as a helper, they have the ability to amplify their own capabilities and productivity. And this is exactly what we're seeing in the tax space today. In the field of financial system transaction analysis, AI is being applied in many fields to amplify existing processes. Some of these are facto determination analysis, capital allowances analysis, R&D claims, legal and professional fee analysis, to name a really old one, client entertainment analysis, mapping your trial balance based on descriptions, and IXBRL tagging. All these areas have seen large improvements in accuracy and completion time rates through existing processes, but we've only managed to get 50 to 60% of the workload shifted into the automated environment. With AI, we can get this as high as sometimes 90 to 95%, a massive, massive improvement. And this is where we're seeing the biggest growth. The number of possible applications will keep growing, but the consistent theme is that AI is currently and will likely for some time be used in discrete areas where there are large amounts of source data to allow the models to learn. In short, your jobs are safe for now, but what you do in your job will change, perhaps even for the better. Over to you, Ben.
Thanks, and Ben, all floor is yours.
Great, thank you so much for the introduction. I'll just share my screen and we'll kick off. So yes, hello everybody, thank you so much, and thank you the BDO team for inviting me along to come and talk to you today. Yes, my name is Ben. I am CTO and co-founder of Rainbird. Rainbird is an AI platform. I'm going to introduce Rainbird to you in a little while because I think it is quite relevant in some of this discussion. Part of what I want to talk to you today about, though, is about the hype that there is in this space and how we navigate some of that hype. What is real? What is the things that you need to understand in applying these technologies in the real world? And I'll maybe give you a couple of case studies along the way to try and bring this to life. Really interesting, actually, Ian, in your introduction, you referenced Skynet in some of the hype that surrounds.
Possibly not the best target audience, I think, Ben. I don't think there's any.
Surrounds AI, absolutely. So this is a chart. I've left this unlabeled. Sometimes when I'm introducing some of the hype that sits in this cycle, I ask people to guess what this might be a chart of. I'll reveal this is actually a chart that shows NVIDIA's stock price just over the last few months in this year. NVIDIA, of course, being the organization that provide the GPUs that are used to power a lot of the training that's needed for some of these new technologies like ChatGPT, and we'll come on to some of those terms in just a while. I think it's really interesting to see this massive spike in the NVIDIA stock price just recently, and it's quite indicative of the hype cycle that we're currently in. You know, we started Rainbird 10 years ago. I've been in this field of AI for probably around about 25 years, and in that time, we've seen these hype cycles come and go. AI is a domain which is very prone to this kind of hyping of expectations. And in part, that's because the term AI is quite poorly defined. It's actually a very broad church. AI describes a whole set of different kinds of technologies and is subject to something which is often called the AI effect or the AI paradox. It was actually best summarized, I think, by John McCarthy. John McCarthy was one of the founding fathers of this space from MIT back in the 1960s. When he complained that as soon as it works, no one calls it AI anymore. And that is so true. Back in the 1990s, when I was studying AI, we would have considered route planning algorithms, so the kinds of technology that powers your sat-nav or Google Maps, very firmly as being AI. But we don't really consider those technologies to be AI anymore. It's just computerization. And that's part of why we see these sort of cycles of hype and expectation, and then reality hits over on the other side. So I think it's quite important to understand the practical applications for these technologies. And part of the problem is because AI is such a broad term, when we talk about AI, we might mean any one of a whole number of different technologies. So I thought it might be quite useful to start by just defining some key terms and diving in. And as Ian said in his introduction, machine learning is something that a lot of people understand as being AI, but it is just one technology in the kind of broad set of different technologies we might consider to be AI. And actually, machine learning itself is quite a broad term. It describes one of any number of different kinds of technologies that are really starting from data and using those data to make some kind of a prediction, typically about future outcomes, but without having to explicitly encode an algorithm to do so. So it's about being able to use data without explicit encoding. A lot of people are familiar with technologies like neural networks or deep learning. These are terms you've probably heard. The press are writing about these things quite a lot. Those are machine learning technologies. Now, of course, the promise of machine learning and being able to make predictions from data has to be met with the fact that, first of all, you need access to those data in the first place, and that data needs to be in a state that it's ready to go and power these algorithms. But also, machine learning technology comes with an inherent difficulty in explainability, in being able to understand why a machine has made a particular prediction. That's quite a difficult thing to do with machine learning technologies. And that opens you up to risks of exposure in making biased decisions or making decisions that are difficult to explain and so therefore difficult to trust. And we'll talk about trust and how you might navigate some of this in just a moment. On the other side of the coin, I guess, to machine learning is symbolic AI. Now, symbolic AI is a term that has been around for decades, but you may not be so familiar with, although it is having a bit of a resurgence right now. And this is kind of the logical approach to solving some of these problems that Ian referenced earlier on. These are technologies like knowledge graphs and rules-based systems. It's really about taking structured models of the world and then reasoning over those models. And one of the really interesting things that's happening right now is kind of a convergence between machine learning and symbolic AI. And I'm going to bring that to life a little bit for you and how you might apply that in your organization in just a moment. And then I've separated out large language models actually as a separate category here, although really large language models sit within this kind of broad section of machine learning. Large language models are typically powered by those transformer architectures that Ian referenced that came out of that Google paper a few years ago, and include technologies like GPT, which powers ChatGPT that everybody's been playing with, and that's currently where the focus of all this hype is. And really, these are machine learning models. That means that they have been trained, as it happens, the large is important. They've been trained on very large data sets, but it's really about making predictions about the world. And the key thing, and there's only one thing that you take away from this session, is that those technologies, that machine learning technologies, are not magic. They are mathematical in nature. And I love this cartoon. This comes from XKCD. There's the links there if you want to go and see the original. It's actually quite old, but it is very, very true even today. That actually this is what ChatGPT and like are really doing. What they're doing is making a prediction about the statistically most likely next word that should appear given the history that it's seen. And that's all they're doing. They're just making predictions. And that's very important because we need to recognize that prediction is not the same thing as judgment. And this is really key to how you go about applying these things in the real world. Prediction is about statistics, is about probability. Judgment is about applying human reasoning or human-like reasoning to turn prediction into something that we can actually go and take action on. And typically these predictions that are made by machine learning tools, including ChatGPT, require human-like expertise, weighing up all the different factors and situational considerations in order to turn that into something that we can actually go and take action on. And that becomes very important. I want to just take a slight sidestep to talk about regulation just very briefly, because this comes quite relevant when we start to discuss trust and transparency, which are key to how you might adopt some of these technologies in real life. As with any kind of emerging technology, I think the regulator is playing catch up somewhat. A lot of the regulators are scrambling around trying to figure out how to regulate in this space, although we may argue that they've been doing that for some years. One of the really interesting things that we've seen just in the last week or so is the draft regulation coming out of the European Parliament, which we might imagine some of the rest of the world may follow suit. So it's worth paying attention to. This regulation is quite broad. It covers lots of different areas, and some of it is very good. Some of it still requires some work. The really interesting thing to understand, though, is that at its core, it talks about ideas of safety, of transparency and explainability, traceability, and data privacy. And these ideas that are going to be baked into this regulation need to follow through in anything that you're using in order to adopt these technologies, particularly when it comes to ideas of trust and explainability. And we think this is actually really important, and trust is very key to the way that you should be adopting these technologies. And actually, we would argue that even beyond regulation, trust is critical to adoption of these technologies. In fact, it's critical for adoption of any new technology. And I love this example, humble microwave oven. Microwave oven invented in 1943, but it took until arguably the late 1960s, early 1970s for it to see the kind of widespread adoption that it really deserved. It's sitting in everybody's home. And you imagine a technology like microwave, which has the ability to go and change people's lives and be a real time-saving device. You would imagine that would have been adopted much more quickly. The reason it took all those years to reach the kind of wide-scale adoption was really because people didn't understand it. People didn't understand, in this case, how food could be heated without a heating element, because they didn't understand it, they didn't trust it, so they didn't adopt it. Same is true in AI. If you're making automated AI-driven recommendations, imagine you're producing reports that recommend some kind of a tax treatment, your end users are not going to adopt or trust that recommendation unless they can understand it. And so you need to be able to explain the reasons behind the decisions that you're making. So we would argue, and this is our hypothesis, that the world needs AI that it can trust. And this really is a problem. And this is a problem because a lot of people, when they're thinking about implementing AI-based solutions, really what they're talking about is building systems that can automate decision-making, because, a rather obvious statement to say, poor decision-making costs money. But then we have these kind of dual competing challenges of a lack of trust that we may try and use purely data-driven approaches like machine learning or statistical analysis to drive our decision-making, but that becomes very difficult to go and explain, and it opens you up to the risk of bias. So then you might fall on other automation technologies like robotic process automation or more linear workflows, but those technologies fall short if you try to automate anything that's beyond simple levels of complexity and scale very poorly. So these two things become quite challenging, and that's a difficult square to circle. Another way to look at this, perhaps, this idea that actually prediction and judgment are two different things, is also to recognize that actually analysis and automation are also two different things. And I think a lot of people, when they're thinking about artificial intelligence, sort of lump these two different tasks into the same thing. I think that what we're trying to do is some AI. Well, actually, analysis technologies are typically machine learning. You're maybe making some prediction or looking for patterns through data, versus automation, which may well be trying to recommend some kind of an action, and that is much more about judgment. As a result, we've kind of seen the world through these two different lenses, like there's almost like there's two different planets. You have planet data and you have planet process. And so over in the land of data, we have all these people, we have all these fantastic things like large language models, and there have been some huge strides. But remember, of course, outcomes are predictions, not judgments, where data availability remains a challenge and models are subject to unseen bias and explainability is challenging. And then over on the other side, we have the land of process, which is really about technologies like RPA, linear rules engines, and so on. A lot of the process folks are trying to make typically bad processes run faster for some benefit. What we're actually seeing, though, is that, of course, these may look like two very distinct separate worlds, but actually they are both part of the same world. There's just a chasm between them. So we can bridge this chasm, and we can bridge this chasm through decision intelligence. Decision intelligence is the bridge that kind of links these two worlds together. And a big part of that is really about not marginalizing your human experts. By building models that start with an understanding of human expertise, which you can then link out to data and do all of the good things that you can do with machine learning, actually you end up with models that are safely deployable, that are open to your own introspection and management, that bring with them inherent explainability that you can go and manage well, always explainable. So introducing Rainbird, we are a technology that bridges that gap between these two different worlds. A good way to think of it is a bit like you imagine machine learning might answer the question, if I know or I see or I'm given data on X, Y, or Z, what can I predict? What patterns can I see? Technologies like Rainbird are additionally able to answer, okay, well, what actions can I take? And that allows you to then go and automate judgment, because this is producing models of human expertise, which automates judgment. And that means that you make better decisions, which lead to better outcomes. How do we do this? Well, actually, this is done through a process of knowledge representation and reasoning. I'll jump in and give you an example of this in practice in just a moment. Really, this is about codifying human expertise. In Rainbird, that's through a no-code interface, so a human expert can sit down and build their models of their world, which you then connect to data to go and produce automations and to go and reason about. The point is that this produces models that are trustworthy. And we look at trustworthy through these different lenses that actually what we're talking about is explainability, reliability, traceability. Where did that body of expertise come from? Why are we making this decision? And then crucially, noise-free. So we talk about noise in the human sense as the variability in the way two different people equally trained may approach a particular decision. And we're able to counter for noise and take it out of the system by automating human decision-making. So Rainbird is a platform technology. You can use Rainbird for automating decisions in a whole bunch of different domains across a whole bunch of different kinds of use cases. A good way to think about it is anywhere where you have high value decisions being made regularly by your human experts, where actually you desire scalability of that decision making, but while maintaining quality in that decision. But also crucially, that you need to be able to explain why a particular decision was reached or why a particular recommendation has been made. And you might need that explainability for regulatory reasons because you want to be able to demonstrate that you've gone through the right steps in making that decision, but also because you might want your end users to have some trust in your solution to be able to understand why a decision has been made. So here are some examples of some of the places where Rainbird is being used today, and some of the kinds of decision making that Rainbird is being used for. It is used in all kinds of different spaces. On the left-hand side here, we've highlighted a handful of different tax examples. I thought it might be useful to perhaps dive deep into just briefly into one of these. And the one that I've picked out is R&D tax relief recommendations, partly because our friends at BDO have built a tool that does precisely this, and Gartner have gone and written about the work that they've done. So what I've done is I've stolen a couple of slides from the Gartner report, which is what you'll see coming up next, that describe what was going on here. So Gartner have in their report have recognized that expert decisions, so decision making that's done by humans, are complex. Are contextual. They're applying the facts of the situation to make the decision, but are also non-linear. That this is not a process of going if this then that. That actually it's more complicated and more nuanced than that. In this particular case, research and development's UK tax credit valuation. Typically, the process may well have been a consultation between the client and a tax expert. The tax expert would then go and take that consultation and all the data that they have at hand alongside their body and their wealth of expertise and make a decision. And that is a time-consuming process. They reported that this could take up to 5 hours to go produce this report. And then the output might be something along the lines of, based on my expertise, we believe that the company might be underreporting their tax credit claim. And by the way, this is why. And you can see here some of the different routes and different factors that might be taken into consideration when making that judgment. Now, to automate that judgment requires more than a linear process flow, but also because we want this to be explainable, we can't lean just on machine learning technology to go and do it. So how do we do that? Well, what we do is we go and build a knowledge graph. The input to this knowledge graph actually is that tax expertise. In this particular case, we sit down with the SME, with the tax expert, and codify their world, along with all of the nuance and subjectivity and ambiguity that there is in the way that people really go about making decisions. This decision in R&D is not something that's necessarily binary. There may be parts of that decision. So, for example, is there uncertainty in this project? Is something that might carry some degrees of uncertainty about itself. But then this allows you to build models that reason in the same way that tax expert reasons, connect that to data, build a consultation and put that in front of a client. Now you're able to automate that process and turn what would have been a process that took several hours down to just a few seconds. So that's the principle on which this stuff is working. So I guess a handful of takeaways. If there's nothing else that you should remember from this session, the most important thing to remember is that AI is maths, it's not magic. And that has implications for the way that you go about deploying this in the real world. We must recognize the difference between predictive technologies and the need to make judgments on top of them. And actually that AI needs to be trustable and explainable. And without that trust and transparency, we're going to struggle to go and get widespread adoption. And very soon we're going to fall foul of the regulator as well. And you can do that by not marginalizing your human experts, by remembering that you have expertise in your organization and using technologies that can leverage that expertise in the right ways to be able to go and connect that to data and to then go and deploy it. So hopefully that was a bit of a helpful overview. I think we're going to go back into some Q&A.
Thank you very much, Ben. Look, appreciate we've had to cram you into 19 minutes, and great job for hitting the time part on that. We've got a couple of minutes left for questions, so please do start powering them into the Q&A area of the chat if you've got anything for Ben. While your fingers are feverishly typing away, I did have one myself. You know, Ben, you and I were at the HMRC event recently where this was being discussed. There'll be a number of people on the call who will have seen the latest feedback from the National Audit Office in terms of MTD and the delays and things like that. But where do you think this will go from a government perspective? How will HMRC adopt some of this stuff?
So, I mean, that's a very good question, and I think a lot of that will depend on the way that the regulator sees things changing. We've seen some other interesting moves. We saw just recently the CMA giving a warning across the bows that they're going to come and investigate this space, not least because the largest and most successful models in this space are in the hands of a very small number of very large organizations. I think there's so much uncertainty about the direction that this might all take. It's a little difficult to know exactly how people like HMRC might end up adopting these things. I think HMRC, like a lot of other organizations, are looking at the way that things like large language models might be deployed to help with some of the grunt work, help with some of the heavy lifting. But just as I describe here, they and others are still valuing the position of the human expert, and I think that won't change.
Yeah, because HMRC obviously they're closing the helpline at the moment for a period, and they're pushing more people towards kind of chat answers and stuff to input their into their knowledge. So there's a few nervous people around how that's going to work and stuff like that. We've got one question come in, which is, what is a large language model?
So a large language model is a machine learning model. So when you use ChatGPT, when you're sitting in front of that tool and you type in your questions and it comes back with an answer, or you're asking it to do something for you, what you're really interacting with behind the scenes is a large language model. And a large language model is essentially a set of mathematics that has been trained by going out to, in the case of ChatGPT, the open internet. So it's gathered in lots and lots of data. It's read all of Wikipedia. It's read the entire works of Shakespeare. It's actually gone and read loads of posts on Reddit. In fact, it's read billions of different things. And what it's done is it's learned from all of that data, all of that text, how to respond to questions that you ask it. But actually, what it's really doing, of course, is learning how to make predictions about what words look right in the outcome, which is why you may have heard the term hallucination in relation to these technologies. Really, what they're doing is predicting the thing that looks right, not necessarily the thing that is right. Hopefully that answers.
And I guess the challenge with the increased amount of data, and Ian and I had this conversation this morning in terms of data that's behind paywalls, and also the volume of rubbish data that's out there, as you say, chat forums and various other things where this information is formed. There's some ideas that we, as tax specialists, wouldn't necessarily concur with, and that's all being fed into these large language models. And some of the information that perhaps is a little bit more curated is perhaps hidden from the large language models because it's proprietary or behind a paywall.
Yeah, that's absolutely right. You wouldn't go to Reddit if you were trying to find the correct tax treatment for a client. You probably wouldn't go to Google and then just rely on the first answer that comes up. But of course, that if you're using ChatGPT to give you that kind of a view, that's really what you're doing, because that's what it's being trained on.
Yeah. We've got one last one if we can answer in 30 seconds. I don't know if I can ask the question, but as tax professionals, we are not AI IT experts. What's your advice to tax professionals if they're to remain abreast of the developments here and not fall behind?
That's a very good question, and that's quite a difficult thing when, particularly in the UK, the media is all over this, and it's very, very hyped and very misreported. There are some more reliable sources of information out there, and I think in particular we're seeing some quite good things being written about narrow applications of these technologies in the trade press. So my advice would be to keep an open mind, to keep reading about where these technologies are being deployed, but avoid the headlines. Avoid there's so much hype and noise, particularly in the national press around this stuff. It's much more important to look at the kind of narrow applications that are being written about these technologies.
Okay, thank you, Ben. Brilliant. Thank you for the questions. And obviously the answer to that one is to ask us and we'll help you answer that question as well. Thank you for Ben from Rainbird. Really appreciate everybody for joining this morning. We will have a little break for the summer and we will come back with more of these sessions. If you've got any topics you'd like us to cover, please do let us know. But thank you very much, everybody, and speak to you soon.